You're listening to the Sustainable Angler Podcast. I'm your host, Rick Crawford. Have you ever heard the phrase, what gets measured gets managed? Well, I use that a lot when working with clients and helping them to understand how to achieve carbon neutrality. Well, how do you do that? Well, first, you need to understand your carbon footprint, so you need to measure it. Then you need to work on strategies to actually reduce your footprint. Then finally, you can purchase carbon offsets to achieve carbon neutrality. Well, what gets measured gets managed is also true when it comes to understanding river ecology and river chemistry. And on today's episode, I interview Science on the Fly founder and Deputy Director and Senior Scientist of the Woodwell Climate Research Center, Dr. Max Holmes. And we take a deep dive into climate change, the effect climate has on river chemistry and fish, and also how Science on the Fly is using citizen science to collect data to better understand and enhance water quality and watershed health. Hope you enjoy. This episode of The Sustainable Angler is brought to you by Emerger Strategies, a sustainable business consultancy whose mission is to solve the climate crisis by helping your business go carbon neutral and zero waste. Emerger Strategies is also a founding member of the Fly Fishing Climate Alliance, is a carbon neutral company, and is also a proud 1% for the Planet member. To learn more, visit emergerstrategies.com. This episode of The Sustainable Angler is also brought to you by Rios Gear, makers of sunglasses that float, that are polarized, and offer 100% UV protection. Rios Gear is also a 1% for the Planet member. They are a Charleston-owned company, and they've recently launched their H2O campaign, which was created to encourage people to fall in love with the water and help them protect it. Rios is selling H2O t-shirts, with half of the proceeds being donated to nonprofits like Charleston Waterkeeper, Charleston Surfrider, and the South Carolina Aquarium. Go to www.riosgear.com/H2OME to watch episodes, claim your shirt, and make a difference. So, Max, we actually had an opportunity to talk on the phone, I don't know, a couple months ago or something, and got to know each other a little bit better. But for those out there listening, would you mind providing just sort of a background on how you got into being a climate scientist and what led you to Science on the Fly, the whole story?
Yeah, sure thing, Rick. Thanks a lot. Thanks for the opportunity to be on here. So, yeah, how did I become a scientist? It probably, I guess I first was a fisherman, and I grew up in different places, but let's say as a young kid, I was in northern Michigan, and any chance I had, I was out, either on a boat with my dad and, out fishing for lake trout or something like that. And then as soon as the boat hit land, I was, messing around in streams and flipping over rocks and trying to catch fish, and just sort of curious about the world around me, like every kid is. And, I often say that, everybody starts off as a scientist trying to figure out how the world works, and some of us sort of stick with it. So, yeah, I really had this, I guess, beginning as an angler, trying to figure out how to catch a fish, like lots of your listeners probably do. And there's definitely a science to that as well. And there weren't really any scientists in my family, but there was a family friend of ours that I always kind of heard about. I didn't meet the guy until I was in college, but his name is Ken Cummins, and he was a stream ecologist, kind of a famous stream ecologist. And what I knew about him as a young kid was he studied trout streams in Montana. So, that was good enough for me. If you can do that as a job, that sounded pretty good. And so I always had that in the back of my mind. And, I kind of went up different roads at, different paths along the way. But in college, I studied biology, and I guess I wasn't sure what I was going to do, but sort of after my freshman year of college, I did pretty well. And everyone was like, well, why aren't you pre-med? You're doing really, why aren't you pre-med? And I thought, well, maybe that's okay, I'll be pre-med for a while, and I did that. I said I was that doesn't really mean much. You're not really taking different classes or anything like that. But I was a biology major, pre-med, I guess, and then I was taking things like genetics and cell biology and all this really kind of focused little stuff. And then my senior year, I took my first ecology class, and that just kind of like, okay, now I remember why I'm really into this stuff. And yeah, forget that pre-med stuff. That's important. Don't get me wrong, but I'm really passionate about the natural world and trying to understand it and trying to protect it. So I started to head down that path, and I still wasn't exactly sure what I was going to do. And this is kind of a funny story, perhaps, but the guy that taught this ecology class, this was at University of Texas, and his name was Eric Pionka, kind of this ornery old ecologist. I thought he was the coolest guy in the world, just this grumpy old dude, and he studied lizards. I was going to go to India with him right after I graduated as an undergraduate to help him, kind of be his field assistant studying lizards in India. And that fell through. The Indian government didn't give us visas. I guess there was some kind of unrest in that area or something. So as a backup, I'd applied to a program at the University of Michigan Biological Station to do some research up there and take a class. And so I kind of fell back on that one and took a stream ecology class there at this amazing biological station, and did some research on trout streams. And like, okay, this is pretty good. This is kind of what I'm into. And I still wasn't exactly sure what I was going to do, but one thing led to another. I ended up getting a master's at University of Michigan in natural resources, and then went to do a PhD at Arizona State University, focusing on stream ecosystems and stream chemistry and so on.
Wow! So, fell in love with the natural world. Takes you all the way to a PhD in river ecosystems, which is pretty incredible and fortuitous for us listening. So I think we're gonna learn a lot on today's podcast. But so after you graduated, where did you go? How did you find work in your field?
Yeah, that's funny, and it still wasn't a straight path by any means to where I am right now, but. So I got my PhD in 1995, and back then, it wasn't a sort of an online world, and you'd look in the back of like Science magazine, the journal, for jobs, and I remember flipping in the back of Science, looking for a postdoctoral position right after I got my PhD, and there was one advertised in Woods Hole, where I am now at the Marine Biological Laboratory, and it was for somebody to work on estuaries in New England, and there were sort of four things listed as requirements for that job. One, something about estuaries, which I didn't really know much about estuaries. I don't even think I could fake it, but, kind of couldn't negative on that one. The next was, something about nitrogen cycling. And that's sort of what I'd done in rivers for my PhD. So I was good there. The third was, something about using stable isotopes in ecological research. And I didn't know anything about that. The fourth was that you work well in collaborative research environments. And so what the heck, I sent in a letter thinking I wouldn't have a chance. I'd never really been to New England before. And, Woods Hole is kind of a famous place for doing science, and sent it off, and somehow they decided to interview me, and then, somehow I got a job. So I ended up being at the Marine Biological Laboratory for 10 years, first working on estuaries for a couple of years, and then I got a chance to do some river stuff and go to the Arctic, and I was totally hooked on that. So I was at the Marine Biological Laboratory for 10 years, which was an amazing place. And then I got the chance to move up the road to what at that point was named the Woods Hole Research Center. And just a year ago, we changed our name to the Woodwell Climate Research Center. But yeah, I've been there since 2005. So 16 years now at the Woodwell Climate Research Center.
That's awesome. And then I know, and we're going to take a much deeper dive into this, but I'm also really excited to introduce everyone who's not familiar already with also your latest project, which is Science on the Fly. Could you give us just a brief background on that, and then we're really going to dive in here in a little while?
Yeah, I'll try to be brief, but maybe I'll give you a little bit on how I got there. And
yeah,
before I talk about Science on fly, I'll sort of talk a little bit more about the science that I typically do, which is, in general, focusing on river chemistry and discharge and how it changes over time, and then what we can learn about what's going on in the river's watershed based on that. So what you see in a river in terms of its chemistry, in part is depends on what's going on, the processes in the river, but to even larger degree, it depends on what's going on in the land around the river, in the river's watershed. So at the Woodwell Climate Research Center, as our name suggests, the big focus of ours is on climate change. And so my science is sort of, again, looking at river chemistry and river discharge, how those things change over time, and learning what we can about what's causing the changes, whether that's being driven by climate change or some other disturbances in the watershed or something like that. So I spent a lot of my time working on really big rivers around the world. A lot of that's in the Arctic, and the Arctic's a super important place for climate change. One, because the warming is greater, so it's happening faster there, and also it's particularly sensitive to warming. And there are really big rivers dumping lots of water and things into the Arctic Ocean. So I've spent a lot of time in the Russian Arctic and working on big rivers in Alaska and Canada, and the Yukon River, Mackenzie River, big Siberian rivers, and sampling those rivers sort of multiple times a year. Our partners of ours sampling those rivers multiple times a year to see how their chemistry is changing over time. We do similar things on the Amazon River, the largest river on Earth, on the Congo River, the second largest, and those Arctic ones are, sort of in the top 10 that I work in. So, and all that takes, it's a wonderful adventure and super important science, but it takes a lot of time and a lot of money to sort of develop the partnerships with people on the ground in different places and the logistics and everything. So that's sort of how I spend a lot of my time. But I've always kind of in the back of my mind, I always want to work in more places and learn more things and see more things and, have more adventures and everything else. And, when I'm not sort of studying rivers as a scientist, I'm not on rivers as a fly fisherman. And I've sort of long felt that there must be some way of bringing these two worlds together because, anglers are around the world passionate about rivers and so on. Okay, there's got to be some way to bring these things together. And it was about 5 years ago, I guess, I had my sister-in-law, actually, her and her husband got a house in Telluride, Colorado. And anyone who knows Telluride would know that if any chance you get to go there, you're probably going to jump on it. If you like mountains and fishing and rivers and everything else. So skiing, my family and I, started to head out there whenever we could and got to know that area. And as any, fly angler would do, you go into the local fly shop and get to know those guys. And it's in Telluride, it's Telluride Angler. I got to know the owners of Telluride Angler, and they got to know a little bit about the science that I do, and I got to learn. I could just see how passionate they were about their rivers and doing anything they could to protect them. And so we kick around some ideas, and then I met a guy, Johnny Lecoq, who's the owner and founder of Fish Pond. In fact, I was checking out your website earlier today, Rick, and I saw right on the cover image, there was Johnny. It was you, but I think you were hosting a panel or something, and Johnny was on that. So yeah, I got to know Johnny, and he shares the same passions for rivers and the natural world and doing whatever could be done to protect them. So it was sort of with, this sort of group of people, Johnny Lecoq and Telluride Angler, John Duncan, Troy Youngfleisch, and others there, that we just started kicking around ideas and thinking about, all right, how can we get anglers, guides, fly fishing guides, to actually, collect some of the samples that you're interested in, send those to Woods Hole for us to analyze in our lab, see how their rivers are changing over time, and then use that information to hopefully to affect change and protect and restore rivers. So we started on with Telluride Angler and just some rivers in that area, San Miguel River and some of its tributaries. And that was about, a little over a year and a half ago. I think they started sampling 8 locations around Telluride every 2 weeks and sending those water samples back to us to analyze. And we're already learning some super interesting stuff there, but that was just sort of the prototype of it. And then we got some funding from Patagonia to try to expand to some additional fly shops in Telluride or in Colorado. And we did that. Then we got some additional philanthropic support and we're able to expand more. And just sort of jumping forward a little bit, we kind of went slowly, and we weren't really sure if this idea would work, partnering with fly shops, partnering with guides, partnering with anglers. But we, put together a website, scienceonafly.org, and an Instagram account. And people just started coming out of the woodwork, volunteering to go out and sample their rivers. It's basically collect a sample every month. It's a pretty simple protocol. 160 ml bottle, filtered water sample, freeze it, and then periodically send them back to Woods Hole for analysis. And yeah, we've just been super gratified and a little bit overwhelmed with how many people want to do this, understand the rivers, participate in the science. And we're up to, it's over 300 sites now that are being sampled every month, over 100 volunteers in 38 states and 6 countries. And we finally had to just we were already just saying no to a lot of people because we couldn't really handle it all at once. And we've sort of had to slam on the brakes and just sort of catch our breath and raise some money. But certainly the vision is to keep growing and expanding, more across the country and globally, and just engage this amazing community that shares the same sort of interest and passion for understanding rivers, protecting rivers, participating in the science, and so on. So it's been super exciting, and it's fun to see something that, a couple of years ago was just an idea that you didn't really know if it would work at all. And it seems that it is at this point. It definitely is. We can see that there's a lot of people that sort of share the same interests.
Yeah, no, that's awesome. And I love that. The one of the things that, because I want to learn more about you talk about the chemistry and the discharge of rivers and what is affecting them. But before we do that, because I do want to take this as an opportunity to educate as many people as we can. I mean, let's just start as broad as we possibly can. And if we're talking about climate change, as a scientist, you add a lot more credibility than me talking about it. So what is climate change? Let's start there, and then we're gonna work our way down.
Yeah. So I mean, in one sense, it's self-explanatory. The words kind of say it. It's changing climates, and I guess it's important to think about what time frame we're talking about. But if you think of over hundreds and thousands of years over the history of the Earth's climate changes. Humans have been around for a couple 100,000 years. Human activities have really only ramped up, in the last several hundred years. But throughout the history of the Earth, the 4.5 billion years or whatever, the Earth's climate has changed, and it's changed dramatically over time, and it's changed in the absence of any human activity. And it's pretty well understood what the reasons are for that. And, part of it has to do with greenhouse gases like carbon dioxide and processes that put more of it into the atmosphere at certain times or take some of it out of it. There are other things certainly that influence Earth's climate. But if you go back, right now, let's see. If you go back 10,000 years ago, the concentration of carbon dioxide in the atmosphere was about 280 parts per million. So carbon dioxide is one of the main greenhouse gases. If you go back longer than that, we can go back, over 600,000 years by looking at gas bubbles that are trapped in ice cores in Antarctica, or a little bit shorter time in Greenland. And we can reconstruct the Earth's atmospheric, the concentration of carbon dioxide at Earth's temperature from those sorts of records. Anyways, before 10,000 years, it would hop around a lot, both the carbon dioxide concentration and the Earth's temperature. Around 10,000 years ago, we hit this really strange stretch where the Earth's climate was relatively stable for most of these past 10,000 years. 10,000 years ago, there were around 1 million or maybe 2 million people on the face of the Earth.
Wow. We
hit this stable stretch of climate, and not surprisingly, Earth's population expanded. When I was born, there were about 3.3 billion people. Now we're at about 7.5. When my great-great-grandmother was born, there were around 1 billion people. So Earth's population is taken off in part because we've been in this really stable period of climate. And then more recently, it's taken off because we've figured out this awesome way to get energy and use that energy to support our lives, to sustain our lives. And that awesome source of energy was in, say, around 1850, the first fossil fuel we started to use was coal. Dig that stuff out of the ground, burn it. It's a really good energy source. Around 1900, we started to use oil. Same thing, awesome, potent energy source. And around 1950, we started to get serious about using natural gas. All of those fossil fuels are called fossil fuels because they're the remains of mainly plants, but also animals that lived millions and millions of years ago, and have just, because of geological processes, have gotten stored away in the earth, not decomposing and just sort of sitting there for us to use. It seemed like a wonderful thing in a lot of ways. It was. What we didn't really realize initially was that the byproduct of that use of the fossil fuels, combustion of fossil fuels, is carbon dioxide is one of the main ones. This greenhouse gas. We've known that carbon dioxide in the atmosphere helps to warm the earth. It's a good thing it does, but without that, things wouldn't be so hospitable for us. But we're pulling vast amounts of ancient carbon out of the ground in the form of fossil fuels and putting into the atmosphere as carbon dioxide and methane, another greenhouse gas. And that's causing the earth to warm. I said, 10,000 years ago, CO2 concentration, carbon dioxide concentration in the atmosphere was around 280 parts per million. It was about that in 1850. Since then, it's been going up as we've been using fossil fuels. And as of today, we're up at 414 or, something over 400 parts per million. And we know where that's coming from. It's coming from burning fossil fuels. Secondarily, it's coming from deforestation. When you chop down forests, burn forests, put carbon into the atmosphere. So we know where it's coming from. We've known for a long time that carbon dioxide is a greenhouse gas. It causes the earth to warm. And that's just well established. There's not a lot of room for argument there. There can be a lot of room, and where a lot of the argument comes in is what's going to happen in the future, and what's the temperature going to be in 100 years? And nobody can really tell you that because, for one, we don't know what decisions we're going to make as a society. Are we going to keep pulling all of the fossil fuels out of the ground that we can and burning them? Are we going to keep deforesting primarily the tropics now and putting that carbon into the atmosphere? If the answer to those questions are yes, it's going to get pretty warm, and that's not going to be so good. If we make other decisions and transition off fossil fuels to other energy sources, if we protect and restore forests, if we do all these other things that we need to do, let's say to combat climate change, you get a very different answer. But yeah, I think a lot of times people take the uncertainty, the range of estimates for what might happen in the future as a indication that, well, the scientists don't really know what they're talking about. There's so much uncertainty about that. And yeah, there's always scientific uncertainty, but the biggest part of that uncertainty, when it comes to projecting or predicting what's going to happen in the future, it comes from the uncertainty about what decisions humans are going to make.
Yeah. And so that's just as I guess a point of, I'll just make this point just because it's an interesting stat that I'm kind of fixated on with what I do with trying to help businesses reduce their carbon footprint, is that according to the IPCC, that's the Intergovernmental Panel on Climate Change, we need to half global greenhouse gas emissions this decade and be carbon neutral by 2050. So just as Dr. Holmes is explaining all of this, we burn fossil fuel, we release greenhouse gas emissions. Okay, now we're realizing we can't do that. It's going to make the earth unhospitable. So what do we need to do? We need to find alternative energy sources. And that typically comes in the form of renewable energy, nuclear, things that don't emit greenhouse gas emissions. And that's sort of where we are in kind of this next decade that is interesting. But I'm just throwing my little tidbit in there. But that's something. If you're listening to this and going, oh well, what do we need to do to fix it? Well, globally, everyone needs to really start focusing on reducing our carbon footprint as quickly as possible. But that said,
that's exact.
Yeah, go ahead.
That's exactly right. I mean, and it's not just sort of switching to renewable energy sources, but it's also thinking about energy efficiency. How can we use less and conserve what we have? But yeah, we have to do all those things that you said. We've got to start to do them in a hurry if we're going to avoid the worst consequences of climate change. And it's a daunting task and a big challenge. But in that challenge. I think there's, we've risen to big challenges before. Maybe this is a bigger one than globally we face, but we've done some really big things before. And when you have something like this, there's opportunity there. There's creativity, there's innovation. All these things need to come to the forefront to figure out how to tackle this thing and make life better, make our future better for the next generation and lots of generations down the road.
Yeah, that's exactly right. All right, so let's talk about. Well, thank you for that, by the way. That's hugely helpful. And let's talk about how is climate change affecting river chemistry? And you're seeing this all over the world. And you mentioned there's some other things obviously that affect it, but I'm curious to know how is it affecting river chemistry? And then as a follow up to that, I'll just go ahead and ask now and then how is that affecting fish?
Yeah. Okay. A lot of different ways. Let me unpack that a little bit. So as I mentioned, I spent a lot of my time in the Arctic, and the Arctic's, it's a super important place when you are thinking about climate change, in part because of permafrost. So permafrost is, permanently frozen ground. And from a climate perspective, what's really important about that is it stores just vast amounts of ancient carbon. Again, this is not fossil fuels I'm talking about, not that old, but maybe, thousands of year old remains of plants and animals that have basically just been frozen away in this frozen ground. So, and there's roughly twice as much carbon locked up in permafrost in the Arctic as there is in the atmosphere right now. So, and when that permafrost thaws, it's sort of like when let's say your freezer is unplugged or it's not working so well and it becomes a refrigerator. What happens when that happens? You start to smell that stuff's rotting away, right? If you go away on a trip or something and come back a week later and your freezer's not working, you got a problem. And that smelling is, or that smell is, that rotting is decomposition, and it's basically bacteria chewing on that food in your freezer and releasing various things, including carbon dioxide and methane. And so that's what's starting to happen in the Arctic now with permafrost is frozen ground as the Arctic is warming. And I think I already mentioned the warming in the Arctic is around twice the global average. So the Arctic's warming pretty fast, permafrost starting to thaw, and that carbon that's locked up in the permafrost starts to decompose, rot, and that releases carbon dioxide and methane, which are greenhouse gases, which then can lead to more warming and so on and so forth. You worry about this self-reinforcing cycle. So, okay, how does that link to rivers? The chemistry of a river, it sort of integrates the processes occurring in its watershed. So we work on big rivers in the Arctic, as I mentioned, Yukon and Mackenzie, people have probably heard about. In the Russian Arctic, we work on the Ob, Yenisei, Lena, and Kolyma. And those are, the Ob, Yenisei, and Lena are all comparable in size to the largest river in North America, the Mississippi River. So super big rivers. Wow. So we've been sampling those rivers since 2003, 6 times per year, looking at the chemistry seasonally and then over longer time periods. And I told the permafrost story because one of the things that we measure in the rivers is the carbon, different forms of carbon that are in the rivers, but also the age of the carbon. So you can radiocarbon date the age of the carbon in the river, figure out how old it is. So what we sort of predicted for a long time is that as warming continues in the Arctic, permafrost thaw will accelerate, and we'll start to see signs of that in the river, the carbon in the river, older and older carbon. And to cut to the chase, we think we're starting to see that. We're certainly seeing that in some of the smaller streams that we sample in the Arctic, and we may be getting indications of that in these really big rivers. So, when I wear my scientist hat, I get really excited about that. Like, oh God, this thing that we thought was going to happen seems to be happening now. But pretty much every other part of me, as a citizen and a parent and somebody who cares about what the future is going to look like, that's not good news, because we want to keep that ground frozen. We want to keep this carbon locked away and out of the atmosphere. So anything that suggests that might be doing something else, it's not good news. So, I mean, that's just one example of the sorts of way that we can use river chemistry to give us clues about what's happening in the watersheds. We measure all different kinds of things, not just carbon, different nutrients like nitrogen and phosphorus, major ions, all different chemical compounds that naturally occur in rivers and look at how they may be changing over time, and then try to tease apart what that's telling us about, the health of the rivers, the health of the watersheds, how they may be changing over time. An analogy I like to use sometimes is that we study river water chemistry like a physician studies blood chemistry. So, if you get your annual physical, they take a blood sample, they measure a bunch of things in that blood. It's a lot of the same things that we measure in river water chemistry. And what they're doing is just, they're using that as an indication, not because they're so much interested in your blood, but they're interested in what they can learn about your health and how it changes over time based upon the chemistry of your blood. So that's the similar kind of thing that we're doing on rivers around the world. And that's focusing on the chemistry. We also are really interested in the discharge and look at how discharge, just the amount of water flowing down the river, how that changes both seasonally and how it changes over the longer term. And that can give us important clues about climate change. And what we've seen in Arctic rivers is that the discharge of these big rivers is going up. So if you go back there, the Russians started measuring discharge of their Arctic rivers back in 1936, way before we did. I said 1836. No, 1936. So, there's over 80 years of data there, and we can see it's a really powerful data set. It's been going up. We think that's related to warming. Warmer air holds more moisture, and there's sort of a transport of atmospheric moisture from the tropics to the poles. You get more precipitation, more river discharge. So yeah, just looking at the discharge of rivers also gives you a climate signal. More broadly, I guess, it's not just, you can learn a lot. It's not just climate change that you learn about by looking at river chemistry. We're working now, around the country in lots of different places where climate change is certainly having an impact, but other human activities do as well. And, we measure things, say, like nitrate or phosphate, which are present in fertilizers, they're present in wastewater. So as you're looking at those sorts of nutrients in streams, they're important elements for streams to have, or compounds for streams to have, but in excess, they cause all kinds of problems. And so those things, those you can often see, let's say, the signature of a wastewater treatment plant beside a river in the chemistry of that river downstream, and that that can have big negative implications on the health of the river and the insects and the fish that rely on those insects that we care so much about.
Yeah, and that's the I actually saw recently that I think Miami-Dade County in Florida is like banning, I guess maybe fertilizer during like the warmer months of the year because of the impact on the bay. Because it's to your point, it's changing the chemistry of the river. It's causing algal blooms and all sorts of other problems, which ultimately affect the fish too.
Yeah, that's right. They have all kinds of problems with, I guess, red tides down there, and a lot of that can be traced to fertilizer. You can go down to any garden center and buy fertilizer pretty inexpensively, and what people tend to do is, because it's cheap, they use more than they need to use. And if your lawn's not using it, what happens to it? It gets into the groundwater, it washes off, and surface water ends up in streams and rivers and lakes, and eventually the ocean, and causes all kinds of negative things. It does in a river. It does exactly what it does on your lawn. It helps stimulate plant growth. And it's important that you have some plant growth in rivers, but you definitely get too much of a good thing, and just this overabundance of algae that's happening in lots of different places, and that that's not good for a trout stream or lots of other environments that we spend our time in.
No, and so we're talking about a healthy river, and you're kind of looking at it from the chemistry standpoint, and I guess it depends on the location of the river. But what are some of the things that you're looking at that determine the health of a river?
The things that we measure let's say on Science on the Fly, for example, and I haven't said a lot in detail about that, but it's monthly sampling, a single 60 milliliter water sample, filtered through a really fine porous filter. We send all the volunteers everything they need to collect these samples. They freeze them away. They send them back to our labs where we analyze for nitrate, ammonium, phosphate, and silica. That's sort of what broadly we call nutrients. also dissolved organic carbon and total dissolved nitrogen. So those are the basic chemical measurements that we make as part of Science on the Fly. We also measure water temperature when the samples are collected. Some other projects, we have a longer suite of things we measure, but Science on the Fly is just so big in so many different places and so on. It's still a really nice, powerful suite of measurements. And yeah, some of those things, again, I mentioned, nitrate and phosphate, or nitrogen and phosphorus are present in fertilizers, present in wastewater. They can give you clues about that. They're also present in permafrost and that may be thawing, it's really, you get a sample or two from a river, or even a year's worth of samples, and you learn something. You learn certainly the concentrations of chemicals in the river vary over the course of a year. They just naturally do that for lots of different reasons. But where it gets really interesting for me is over the longer term. And if you start to see change over the years, then you know that something's really going on here. And maybe it's concentrations of nutrients are going down, and in general, that's a good thing. That's suggesting that things are getting cleaned up. But maybe it's going the other direction. And that would raise a red flag, and you'd look at, what's causing that and so on. So, yeah, we're pretty, like I said, a year and a half overall on the Science on the Fly, but most of the sites that are being sampled are newer than that. Already we're seeing some things that kind of jump out at you like, oh, wow, that's, what's going on here? And let's figure out what's happening. In this particular site, this is way out of range of what we're seeing in the region or the other places we're sampling. But yeah, what's really keeping me fired up is just to look at how change happens over, how it unfolds over time. And yeah, I certainly hope that we'll see things heading good directions in lots of places, but I'm sure we'll get some unpleasant surprises too. One example, I was just talking to trying to think how I want to put this one, because I'm not sure who wants this out of the hat. Let me just say that there was one of the sites in Science on the Fly where they had some high nutrient concentrations, and it seemed to be related to wastewater treatment. And apparently, one of the wastewater treatment plants had some issues recently and dumped a bunch of sewage or minimally treated stuff into the rivers. And we haven't analyzed those samples yet, but I'm excited to do so and see what it shows and provide that information to him and to anybody else to help them understand what's going on in their rivers and then what can be done about it. One important point I'll make is that all of the data that we produce are publicly available. So if you go to scienceonthefly.org, there's a page called The Rivers. There's a link there to all the raw data, but there's also some maps that show some sort of average concentrations in different places. So yeah, we want this information to be used by anybody who finds it interesting or has, can put it to use.
Yeah, no, and I think that's part of the interesting thing, and from wearing the hat that I wear and what I do with working with businesses, it's the same. The data, right? It's from a business standpoint, you're not going to manage what you don't measure. So if you have no idea what your carbon footprint is, there's absolutely no way that you're going to be able to reduce it. You can do things anecdotally, like, yeah, I can switch to LED or I can do these things, but I don't really know how much I've reduced my footprint or anything like that. And with what y'all are doing and getting this data that had maybe historically not been being measured in a lot of the rivers that anglers love to fish in, which I think is super cool and will be awesome over time, is to then be able to say, no, we started measuring it and now we actually can manage it. And it's all coming from citizen science, which is really an amazing concept and really cool to have people who are going, yeah, I fished this river. Or to your point earlier of, hey, I grew up playing in this river and I want to make sure it's there for my kids and my grandkids. And these are the types of, I think, and correct me if I'm wrong, but these are the types of things that once they're measured and you can analyze it and manage it, that you can affect positive change.
Yeah, that's exactly right. One kind of thing I didn't anticipate, but maybe I should have, is that, we've got people that, have been living beside the river that they're sampling their whole lives, or been fishing it for decades or something like that. And and just are absolutely in love with their river. And what several of them are telling us that's just super motivating to me is that they have a new appreciation for their river after they've started to look at it through this different lens and collect these samples and look at the chemistry. And it makes them all the more in love with their rivers and all the more motivated to do whatever they can to protect those. We've also had several people that have taken their kids out or grandkids out to participate in the sampling and just told us really exciting stories about that and how meaningful it was both for the kids to be involved in this scientific process or grandkids to be involved in the scientific process, but also how much satisfaction that gave them as as the stewards, let's say, of the rivers, and how it reflected on them that's through the eyes of their their kids or grandkids.
Yeah, that's amazing. Well, what do you are? So we kind of talked about science on the fly, and I also do want to cover this because again, I talk about this stuff a lot, and I work with businesses. My focus is on business and mitigation, but I want to take this opportunity to also ask a scientist. How is climate change affecting fish, right? I mean, whether it's marine or cold water species, what are some of the things that the science is telling us that is happening to fish as a result of climate change?
Well, yeah, let me start with cold water species because maybe that's the easiest one to understand in a lot of ways, is the most direct. It's if you're a trout, you like cold water, and if your stream's warming up as it is in lots of different places, including in a lot of the, let's say, the iconic trout streams in the U.S., that's not a good thing for a trout, and it's I haven't had the opportunity to fish in rivers in Montana for a long time, but I understand that a lot of those get shut down for parts of the year, times of the day, because they're getting too warm and the fish are getting stressed out, and if you want to, so that's really striking. These amazing iconic rivers in the West are getting too warm for trout to do so well in. So that's a clear one, and their projections out, over the coming decades that the trout are going to be wiped out of a lot of the places that they currently exist if we don't kind of turn things around and limit warming. So that's one. In the ocean, not only is ocean warming, but its acidity is changing. So as you put more carbon dioxide in the atmosphere, that's absorbed into the ocean. That changes the pH of the ocean, and it does some bad things for some ocean organisms that make shells and that form the base of the food web in a lot of different ways. So you start to wipe out the base of the food web. That trickles up and impacts, the salmon and everything, the fish and the other things that we care about. So that's starting to happen. You get back to Arctic examples. If you get permafrost thaw, you get increased erosion that can cause issues in streams and covering up spawning beds and everything else. So yeah, there's lots of negatives. There's all different ways. Climate change is a really broad thing, and it's it's not just that the air is warming, but this changes in precipitation, which change the hydrology and the discharge of rivers, which can have all different kinds of implications, and bigger floods. And, it just goes on and on and on. And it's not to say that it's all a bad news story and that everything's a negative, but in balance, it certainly is shaping up to be that way. And so, yeah, for all of us that care about rivers and oceans and fish, and fly fishing and getting out there and care about our kids and grandkids and so on having similar opportunities, it's time to get to work because, we're really kind of at I'd say that, well, I don't know where it's all going to end up because I don't know how quickly we're going to slam on the brakes, but I'll say, potentially we're kind of at the tip of the iceberg here and we're already seeing some pretty dramatic changes. I think most people are, even in the last year, I think a lot more people are actually recognizing that and feeling it than they ever have before. I mean, I've talked about friends and family in the West that, they want to get out of there at times because of the fires. You can't get out of the smoke. And that's climate change. That is climate change that's impacting people. And it's not to say that there aren't other elements, but that are influencing it. But essentially, if you start to heat things up and dry things out, you're more likely to get a fire, and that's happening in lots of different places. So I don't even remember what the question was, but the answer to both.
That was perfect. I just wanted to hear some examples from your perspective, and that's an excellent summary. And I'll just to add to that, just as a personal, I guess, testimonial of sort of what we're seeing. I'm in Charleston, South Carolina, and we're seeing sea level rise here, increasing numbers of days where we're flooding, and we're also seeing. I mean, they don't call it the low country for nothing. That water. This is going to be an area that gets hit first as water. There's more water in the ocean, right? From melting glaciers and every precipitation and everything else. But someone also recently caught a trophy snook in Charleston Harbor. So we're seeing changes in migratory patterns. And I've always heard that there were, you could occasionally find some like juvenile snook in the low country. But they typically died off in the winter because they can't survive a freeze. But that tells you that the winter are mild enough that they're able to survive. So maybe they'll start thriving. So I don't know that if I'm being honest, will be upset that there's snook in Charleston, but it is an observation and some of the things that we're seeing. But all of that is to say, and you mentioned this, saying that there are these changes that are happening, and they we tend to focus on the negative. What are some things that give you hope, and what are some things that are any success stories maybe from Science on the Fly or y'all's research that you're doing, anything like that?
One thing that gives me hope, and this is sort of a Science on the Fly example, I already sort of mentioned it, but the number of people that care and want to do something to help. And I think there's a lot of people out there that recognize that climate change is a problem and they don't know what to do. And in Science on the Fly, there's all these anglers just sort of coming out of the woodwork and saying, okay, here's something where I can actually make a contribution in terms of helping to understand the science, and then hopefully use that science to affect change. So that makes me hopeful, and it also just sort of motivates me, that seeing all these people kind of rallying behind a cause. It also makes me hopeful, again, and this is kind of paradoxical, but it's people are starting to see and feel climate change. And yeah, I wish we had the foresight to listen to kind of what scientists have been saying for decades now and take some action a while ago, but we haven't done that so much. But now when it's starting to hit us in the face a little bit, it's sort of a wake up call, and we can still change the direction of things at this point. And I think, and I hope that enough people are recognizing that we'll have the motivation to do so. One thing that's, in my view, a terrible shame is you don't have to go back too far to when climate change and science in general it's always a political issue, but not a partisan issue, and all sides can get behind, okay, we got to protect this world. Climate change is a threat. We've got to do something about it. And, I don't know, 10, 12 years ago, something like that, there started to be this divide. And that's, I think, terribly unfortunate. And it didn't have to be that way. And we gotta get past this, because, the science is the science. Yeah, we can argue about what the best way forward is and what the best policy solutions are for big challenges like climate change. But, the facts are the facts. And I think that the role for politics, and even for partisan politics, is to debate the best ways to tackle this moving forward. And that's, totally appropriate. And that's the way it should be. We need to get away from, the idea that this is all some kind of a hoax or something like that, which, I don't know whether to laugh or cry when I hear that, because, as somebody who kind of works in this space, that either means I'm in on it or I'm being fooled. And I can tell you, I'm not in on it. And I hope I'm not being fooled. Another way, as somebody that has some responsibility in trying to manage scientists, as the deputy director at the Woodwell Climate Research Center, it's a little bit like herding cats. and they're independent thinkers, and there's no quicker way to get famous as a scientist, or science kind of works by makes big advances by somebody kind of bucking what everybody else is saying. And, oh my God, if I could demonstrate to you that this was all a bunch of junk and that the Earth's climate wasn't changing and we had nothing to worry about, not only would I be the most, famous scientist on the face of the Earth, I'd be the most important, and I'd be given a really positive message. And the fact is that there are fleetingly few scientists that are trying to say at this point that climate change isn't real, that it's not a threat, and that humans aren't driving it. So, if I could say that, I'd be at the head of the class for sure, right. Screaming that as loud as I possibly could.
Well, what is, and I get asked this, and sort of my I'll ask you first, and then I'll just sort of see how your response is. But I know I keep going back to this, but I know what I know. It's just what I do. For me, it's like if I talk to a business and they're going, "Hey, I'm in the fishing industry or business, what can I do?" And, the answer is easy. Well, you can reduce your footprint, and then maybe try and educate your customers on the climate science, and hopefully they can then apply pressure on their elected officials to address this and affect change in that way at the policy level at a scale that's necessary to move on something like this. But is there any tips or anything you could give to the individual angler? I can think of one, but I'll be quiet. That they can do to take action.
Yeah, well, first I'll say that the answers you gave, I think, are great ones. We can all look at our own, let's say, energy use and think about how to, use less and transition to renewable energy sources. We can talk to people and encourage them to educate, encourage them to do the same. If people run a business, they have a fly shop or whatever, you can talk to your customers, you can sort of set the example. One thing I love about the fishing community and the fly fishing community is that it's diverse in terms of, views on science and climate change and everything else. And what I often find is, scientists working in this area, if I go give a talk about climate change, the people that come and listen to that presentation is sort of preaching to the choir. And I love it. In the fly fishing community, there are a diversity of views. And I'm also in that community. I'm equally happy talking about my favorite 5-weight fly rod as I am talking about climate science, so I like to be in that community. I like that, there's a range of views on things and we can talk about things. And my hope is that, when you share ideas and perspectives and backgrounds and stuff like that, you open some minds a little bit and it makes a difference. And I think there's, again, it's great to get out of the bubble of people that just think the same way as you do on issues. So I welcome that.
All right. So now I've got to shift gears, and you mentioned this and reminded me we're on the Sustainable Angler. We've been talking about fish and we've been talking about climate change, but we haven't really talked about fishing. So you've traveled all over the world through your work. Any memorable species that come to mind, or have you had a chance to fish when you're working? Or
yes. Boy, some stories. I'll tell a few probably, but one that I love, and I was on a Lena River in the Siberian Arctic. The Lena is, this massive river. We had chartered a boat, for 130-foot boat on the Lena River for 2 weeks, and we're up near the Lena Delta, near the Arctic Ocean, tundra, just incredibly remote wilderness area. And there was sort of a storm, and we had anchored up for a while, and we took a little boat to shore. This is like a Mississippi River size thing, no dams, unregulated, and we're at like 70 degrees north, and this beautiful stream coming out of the mountains, tundra, just wild. And, I don't know if anyone had ever fished there before. They probably never, I can't imagine anyone that ever fly fished. And, we had a little time to kill. So and I had no idea what, if anything, was there. And in the course of an hour, we caught 3 different species. The only one I recognized were grayling, Arctic grayling, really beautiful fish.
Yeah.
The other 2 were, they're clearly in the trout salmon family, but they weren't any ones that I had seen before,
Really?
or knew what they were. But we took some photos, and so we could figure it out later. And one of them, it sort of looked like a rainbow trout, but with a different mouth. And they're lennic. They're a trout, lennic, that I didn't know anything about. Really beautiful.
Yeah, I've never heard of that.
And the other one, I didn't know what it was. Probably 2 feet long, pretty skinny. I found out it was a taimen, and at that point, I didn't know what a taimen was. I don't know if you know what taimen, but they're the largest salmonid. They get up to 100 pounds. It's kind of this life fish that you try to catch, and we were catching several of them in an hour and had no idea what it was. So that was a neat experience.
That's amazing.
I'm actually looking out my window right now. I see I have a raft sitting in my yard. It says Science on the Fly on the side. So we got 5 of these rafts, and this will be in Alaska pretty soon, and we do some work on some rivers in Alaska, and we'll be floating down one of them, if all goes as planned, or 2 of them actually in August, sort of 10-day floats. I'll be on the Kisaralik River. We'll have other people in our group on the Kwethluk River. There's this series of 7 rivers in Alaska, right on the edge of permafrost. So they're sort of the southern extent of permafrost. So that's going, and we're interested in that. Collecting water samples, putting temperature sensors in the rivers, but they also have all 5 species of Pacific salmon and amazing rainbow trout and Dolly Varden char, and you're spending hours per day floating down a river for 10 or 12 days, and you can imagine there's a fair amount of fly fishing that goes on there. So that's just an amazing experience. I've caught fish in the Congo and Africa that I didn't know what they were, and still don't. I get to some crazy place in the Amazon. I was on a trip in the Amazon a 2 years ago, I guess, and taking some casts and seeing what happens. And I caught some peacock bass, which is pretty cool.
Oh, that's awesome.
So it's a nice perk of the job to work on rivers around the world and. Get to throw a few flies.
Well, you seem to have figured out certainly what I'm trying to accomplish, which is, trying to get paid to fish. So we're going about it in different ways. I think you've got it more dialed in than I do for sure. But I just want to know how do I become a research assistant in Alaska?
Yeah, we've got a pretty long list, but you're doing one thing that we like, which is telling the story. And a big part of the model of impact for science is do the science to get the scientific understanding, but then tell the story. And there's all different kinds of way of doing that, but a podcast is certainly a great way. So we've partnered with filmmakers, we've partnered with a bunch of people who are kind of storytellers, and that's So you never know, right?
Well, that's awesome. Well, Dr. Holmes, I think that's a pretty good note to wrap on. I appreciate you taking the time to do this. It's a real treat for me. I don't get to interview as many scientists as I'd like, and so it's like I read a lot, but it's hearing it from the scientist's mouth is far more powerful, I think, than saying, "Oh, I read this and this is how I interpreted it." But so thank you very much for your time and for everything that you have done and continue to do to protect the rivers that we all love. And I do want to make one last mention. Where can people find out more info on Science on the Fly again?
Yeah, so we have a website, scienceonthefly.org, an Instagram account that's Science on the Fly. You can also go to the Woodwell Climate Research Center's website and learn about both the, overall what we do there, as well as Science on the Fly, and that's woodwellclimate.org. And if you just sort of like Google my name, I don't know, Max Holmes, Arctic Earth Science, you'll find my contact information, and you can tell me all the ridiculous things I've said in the last hour, or ask some questions or whatever. I'm happy to take all compliments.
Awesome. Well, thanks so much. Thanks for listening to The Sustainable Angler. Special thanks to Dr. Max Holmes for his time and insight and everything he's doing to protect what he loves. Also, thanks to the support from Rios Gear. If you like what you're hearing, do me a favor and leave a rating and review on iTunes. That helps us expand our audience and hopefully educate and inspire more anglers to take action. Thanks and have a good one.